Hello class, welcome to lesson 8.3 on similar triangles, AA similarity. So for the essential question today, our goal or the essential question is how do we use AA similarity criterion to solve problems and prove triangles similar. Okay, so now we're going to look at specifically triangles. How do we determine similar triangles? What are some theorems for that? And we're going to start with AA similarity in this lesson. So AA similarity, AA stands for angle, angle. Just like before when we looked at congruence theorems for triangles, for example, SAS, things like that. So remember that in similar triangles, all the corresponding angles are congruent, and all the corresponding sides are proportional. But we don't always have to show that all the sides are proportional and all the angles are congruent. We can get away with shortcuts. And so one of the shortcuts is the AA similarity postulate here. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles must be similar. All right, so here it says example 1, determine whether the triangles are similar and explain your reasoning. So remember, in order to do this, we're going to use AA similarity. So and notice that if you look at this triangle and you compare it to this triangle, they share an angle. In this case, they share angle L. And so we can say that angle L is congruent to itself by the reflexive property of congruence. So we can say angle L is congruent to itself. And next what we could say is that if we look at LPQ, which is this angle right here, notice that this angle is congruent to this angle right here, LJK. Now we got that these two sides are parallel, and so we got ourselves a sandwich model. Remember that if you got two parallel sides and you got a transversal, then we know that the angles here must be congruent because they're corresponding. Okay, so that's called the corresponding angles theorem. So therefore we have A and A. So angle, angle, and angle, angle. And therefore, the triangles must be similar. So we know that triangle KLJ is similar to triangle QLP. All right, go ahead and pause the video and see if you can do the check. All right, so hopefully you pause the video and see if you can examine your reasoning here for the following problem. It says determine whether the triangles are similar and then explain. So here we clearly see that these two triangles are right triangles. We got A here. Let me do that in red, so angle. And we need to see the third side. Now, we know that this is 44. We need to figure out what this third angle is to see if it matches up with that, okay? So remember, the angles in a triangle add up to 180, right? So we can figure out, so to get this one, it's going to be 180 minus 90 minus 44, which is going to be, in this case, 46 degrees. All right, so this is 46 degrees. Well, notice that 46 does not match up for 47, right? So it cannot be congruent. So we're going to say that the measure of angle A does not equal to the measure of angle F. And so the triangles are not similar since we can't use AA for it. Okay, so they're not similar. Okay, so let's look at example 2. Really short lesson today. So use parts of similar triangles. So DeMarco is teaching Tay how to play handball. Tay prefers to return the ball on a serve when it bounces to the height of 42 inches. When DeMarco serves the ball, where should he aim for the ball to hit the front wall to ensure that it bounces at the short line and up to Tay standing 11 feet behind the short line? Assume that the angles formed by the path of the bouncing ball handball are congruent. Okay, so create and describe the model. Okay, so first thing, the ball should bounce at the short line, 25 feet from the front wall. So here's the model. This is from the front wall, 25 feet from the front wall. The ball bounces. So we have the ball here, and then it bounces, right? And then it says the ball should bounce to Tay, who's standing 11 feet from the short line. So Tay here. It says this is Tay. He's 11 feet from the short line. Okay, and then the Tay will hit the ball when it bounces to a height of, it says, in the problem it says here, Tay prefers to return the ball on a serve when it bounces to a height of 42 inches. Okay, so we got the height of 42 inches. So that's important right there. Find the point on the front wall, X, where the ball bounces. So we need to figure out, okay, what is this height where the ball bounces? So if you were to throw it and then the ball bounces, where does it hit on the wall? You can model the path of the handball using two triangles. You're given that the angles formed by the handball are congruent. That's what they said in the problem. So notice that we're looking at So we're looking at this triangle right here, which is a right triangle. And we're looking at this triangle right here, which is also a right triangle. So we're looking at those two triangles. So the front wall forms a 90-degree angle with the ground, and the height to which the ball bounces forms a 90-degree angle with the ground. Therefore, the two triangles are similar. So if you look at the two triangles there, they said, okay, if the ball's here, this angle right here. Okay, so in the original problem here, it says assume that the angles formed by the path of the bouncing handball are congruent, right? And so they're saying that this path, okay, so these two angles are congruent. So in that case, we got A, and then we got A for the second angle. So these two triangles must be similar by AA, right? That's what we're looking at. So we have two similar triangles, and so we can set up the proportion, right? So we say, okay, X matches up with 42, right? So X is to 42, or in other words, 42 is to X. But before we do that, let's answer the question. It says, therefore, the two triangles are similar by the AA similarity postulate. Okay, so now that we know that they're similar, so we said X is to 42, right? So we got 42 is to X. And then let's do another color. So this 25 matches up with 11, right? So 11 matches up with 25, which is what we got here. Okay, good. So we got 42 is to X as 11 is to 25. Oh, we got to convert this to feet, right? So we got 42 inches, which we need to convert feet to inches. So we know that there's 12 inches in a foot. So we got 42 times 42 divided by 12 is equal to, so let's see what that is. 42 divided by 12 is 3.5. So it's 3.5 feet. We want to make sure that the units are the same, inches, feet there. Okay, so it's 3.5 feet. Okay, so we got 3.5 feet over X, okay? And now we're going to cross multiply butterflying. So we're going to do this right here. So we get, and we'll show our work off to the side. So we get 11X equals 3.5 times 25. So let's see, 3.5 times 25. So what is that? Let's do that. So we get 87.5. Okay, so we got 87.5, and then divide by 11 on both sides to get x is equal to, so we get 7.95 feet. Okay, so DeMarco should aim for the ball to hit about 7.95 feet, or about 8, so it rounds to 8, so about 8 feet above the ground on the front wall. All right, guys, that's going to do it for the video. Hope you found this useful and informative, and as usual, I'll see you in the next one.